I'm Diego Vega, and this is my focus project. I'm gonna talk about Kepler's laws. Kepler's first law of planetary motion said that all the planets move around the Sun in elliptical orbits with the Sun in one of the foci. What does first Kepler law mean? Ellipse is a shape that is a kind of a squash circle. Its foci are 2 points in the ellipse to describe its shape. For any point on the ellipse, sum of that point's distance to the foci is the same. If the foci have a large distance, more squashed the ellipse is. If the foci are too close, it's just a circle. In reality, orbits are never perfectly circular, but we do know that the Sun will always be one of the foci of the elliptical path of an orbit. That the Sun is the foci tells us a lot about the shape of that orbit. Kepler tells us that the orbits are ellipses which have a determinate eccentricity. What is eccentricity and how is it determined? Eccentricity measures how flattened an ellipse is compared to a circle. We calculated it using this equation. So what does that mean? Well, A is the semi-major axis or the longest distance axis. B is the semi-minor axis or the shortest distance axis. The equation is the way to compare these axes to describe how square is the ellipse is. An ellipse with the zero eccentricity is just a circle. As eccentricity increases, the ellipse becomes flatter and flatter, and the end looks like a line. An orbit of eccentricity lower than 1 is no longer an ellipse, but a parabola if E is equal to 1, or a hyperbola if E is greater than 1. The giveaway of Oumuamua, the first interstellar comet that passed around here, with an eccentricity that is 1.2. The eccentricity of Earth's orbit is just 0.0167. Kepler's third law said, the square of the sidereal periods of the planets are directly proportional to the cube of their distance from the Sun. And what does that mean? It's the same that how long a planet takes to go around the Sun, its period is related to mean of the distance of the Sun. That is the square of the period divided by the cube of distance is equal to a constant. For every planet, no matter its period or distance, that constant is the same number. Kepler's second law tells us that a planet moves more slowly when it is farther from the Sun. Why does that happen? Well, as a planet orbits the Sun, it may not have a constant speed, but have a constant angular momentum. Angular momentum is equal to a mass of a planet times the distance of the planet with the Sun times of the velocity of the planet. The angular momentum doesn't change when the distance increases, the velocity has to decrease. That means when the planet is farther than the Sun, it slows down. Kepler's second law deals with the speed of a planet orbit in the Sun, so that it tells us in which point the Earth is more speed. The second law tells us that the Earth moves fastest when it's closest to the Sun, or at its perihelion. That happens in early January, and that point Earth is 92 million miles from the Sun. Meanwhile, it's at its slowest in early July, and its farthest point from the Sun, or aphelion. That distance is around 95 million miles. That difference of 3 million may not sound like a lot, but the sounds it makes a lot of difference with the speed of the Earth.